Okie dokie, in this video we are starting Math 1026 Homework 3 on areas and definite integrals. Starting with number 1, they say explain the difference between an indefinite integral and a definite integral. So roughly the idea is indefinite integrals have just the integral of f of x dx, or some function dx, and they do not have bounds in the boundary places here. So what it gives you is the antiderivative of f of x plus c. So what it does is give you sort of a family of antiderivatives, so an endless kind of like general antiderivative situation. Whereas if you integrate with definite bounds, a definite integral of f of x dx from a to b, you will get f of b minus f of a, the antiderivative at b and at a, then the difference between the two. So what it gives you is a specific numerical answer. It results in a particular number, where on the other hand, indefinite integrals result in a set of functions, a family of functions that share the same derivative and uses an arbitrary constant of integration, the plus c. So a is our best choice here. Number 2, approximate the area under the graph of f and above the x-axis with rectangles with n equals 4. And we have our f and our bounds, 5 to 7. We are using left and right endpoints, and then averaging the two answers, then using midpoints. Okay, so let's talk about how to go about this. So my best advice would be to set up a little chart with x and f of x values, starting with 5 and eventually going to 7. But we need to figure out what the width of each rectangle will be, the delta x. So the way we find that is by doing b minus a divided by n. So in this case, b is the far endpoint, the 7. A is the closer endpoint, the starting point. 5 and n is the number of subintervals, the number of rectangles, so 4. So we get 2 over 4, which is 1/2. So what this tells us is the width between each, the width of each rectangle, in other words, the distance between each x value here. So 5 is our starting point, 5.5 is the next, 6.5, and then 7 finishes it out. So we have all these x values, and from these x values we want to find the f of x values. So we plug them into 8x plus 6, so we get 8 times 5, which is 40 plus 6, so 46. Next we have 8 times 5.5, which would be probably 40 times 40 plus 4, so maybe 44. And then plus 6, I guess 44 plus 6 would be 50. And then 6 plus times 8 is 48, plus 6 is 54. So we're picking up on a pattern here. What's happening? The f values are just increasing by 4 each time, so we'll just go 58 and 62, and we should be safe to do that. So once we get these values, let's talk about left endpoints and right endpoints. So for left endpoints, when you think about 5 to 7 on a number line, maybe more particularly on a graph, think about the rectangles that are created in between here. So we have 4 rectangles, one from 5 to 5.5, then the rest onward, you can see where they are. Left endpoints, what we want to use is the y values for the leftmost endpoints, I guess, for each of the rectangles. So like this y value will approximate this rectangle. This y value will approximate this rectangle, and so on and so forth. And so we, for left endpoints, want to use these 4 f values. And we do not want to use the last f value. In other words, the f of x value at x equals 7. So that was a very long-winded way of saying, to find the area of these 4 rectangles, we want to take the width, which is 1/2 or 0.5, and multiply by the sum of all the heights, 46, 50, 54, and 58. Calculating this will give us the left endpoint sum, left rectangular sum. So we can do that in a sec. But part B, we'll do the same thing, except we will leave off the far left endpoint and actually use 1, 2, 3, 4 f values. So we'll use these 4 f values for a right sum. So the idea is we're using the right corners of each rectangle to approximate the height of each rectangle. So we will use the 50, the 54, 58, and 62. So let's find the difference here. We probably do most of this by hand. Let's see. So I'm too lazy. We get 208, and then we're multiplying that by 1/2, so we get 104 for this first one. So we get 112 for this one. And so that's the left and right sums. Now they ask us to average the answers in parts A and B. So averaging these values, we would do 104 plus 112 divided by 2. That would give us 216 divided by 2, so 108. And in part D, they say use midpoints. So let's talk about how we can calculate the midpoint sum. So in order to find the midpoint sum, what we have to use is actually the midpoints of each of these previous x values. So 5.25, 5.75, 6.25, and 6.75. So we need to make a whole new chart here. 5.25, 5.75, 6.25, and 675. So let's plug these into 8x plus 6, our function, starting with 48. Picking up on a pattern here, it's also going up by 4 each time. So if we keep going up, we get 56, and then we get 60. So the nice thing about this is we are using just all 4 of these f values to approximate the heights of the 4 rectangles. So it's like the middle of each of the rectangular edges is giving us the heights of these rectangles. So to get the midpoint sum, we start with the width, which is still 1/2. No matter what, it's the rectangle still have a width of 1/2. And then we just add up the heights. We get 216, and then when we multiply it by 1/2, we get 108. So notice how the average in the previous part was 108, and the midpoint sum is 108. This is no coincidence. It's not always the case, but it is the case whenever you have a linear function like this. So it's just constantly increasing at the same rate at all points. So anyway, that was the first 2 problems. I feel like we've spent enough time there. I'll pick up in the next one with number 3.